This video will show you a little bit more about what you can do with tables in ArcGIS Online. I've got the table open here of that data-enriched county layer that we made in the last assignment. Just reminding you that you can always sort by ascending or descending alphabetically and numerically, depending on what the format of the particular field is. You can also do some statistics on numeric fields, finding out what the sum, minimum, maximum, average, standard deviation is. And even if you had just some selected rows, it would have just done the statistics on that. You can show and hide different columns. It is a little annoying though, because the minute you start to do something in the column, like calculate a new field, it turns all the columns back on again. So it does seem like that could be fixed so that it would stay off, because I had to turn them on and off a few times just to work through this particular example. Just as a reminder, like as in Excel, you can hover over the line between two fields and change the width of a field, but normally that's probably not something you really need to do. So you can add a field in a table as long as you have permission to edit and we do this one because remember this one was a resultant layer that we saved in our own content. The original population data you couldn't do this on because that data didn't belong to you. You were just pointing to data on the Living Atlas. So I want to calculate the population with the 2020 population per square mile. So I need to calculate the county area, which happens to not be in this table. And once again, as I said, every time I do this add field or calculate field or whatever, it turns the columns all back on again. So I have to go back through and just turn on the few columns that I want to see for this particular exercise I'm doing with the table. So just to say what these different populations are, that first population is probably an estimate of the 2020 population that they did a few years ago. And then we've got our population from 2010, and then we've got our population from 2020 that we know is true now. Well, as true as the census is, because that data has actually been released. I'm just adding in the county and the show hide fields. I had forgotten to turn that one on. So since I'm trying to calculate some spatial operation, I actually have to use the arcade program in order to do this. Fortunately, it's got a built-in function for calculating area. I'm going to do the geodesic area just because I'm pulled out a little bit further from the Earth, so the curvature is probably coming into play a little, and I don't want it in square meters. I want it in square miles. So I'm just going to overwrite the meters with the word miles. And then OK, and it will go ahead and calculate. This shouldn't take too long since it's just 95 counties. And there we go. Now we have the population per square mile of this one too. Well, have to add that field in. First, I just calculated the area. Now I have to actually calculate the population of 2020 per square mile. So I do have to add another field. So that's two fields I'm adding. One to just calculate the county area, which I did with Arcade, and now another one where I can calculate the population per square mile, which I'm actually going to do with just plain old structured query language, because this is just a simple mathematical function of taking one number and dividing it by another. Double just means it can have some decimals. So now, once again, they all get turned back on again, which is kind of frustrating. But if you come way over to the far right, you can see, in fact, that we have calculated population per square mile. Oh, actually, that's what we're doing right now. And as I said, I'm doing it with structured query language because it's pretty straightforward. So just total population divided by that county area that I just calculated. In Pro, it's a little less clunky than this. It's definitely a little clunkier in ArcGIS Online, but not too many iterations of this program ago, this wasn't even possible to do. So just the fact we can add and calculate fields is helpful for sure. So now we have our new value based on the actual census data from 2020. Okay, the next cool thing we can do with tables is we can add a non-geographically referenced table with data in it. This is using those HUC-8s, and I've just typed in some fake data of the number of research projects that are being conducted in each one of these HUC-8 watersheds. You can save the data in either Excel or as a comma-separated value file, but you do have to make sure that those HUCs are in string format, because otherwise they're going to come in as a number and they won't match the HUC that we have in our layer in our content, which is string. And it's string because it's got a 0 at the front. Because if you don't make it string, then that 0 would disappear. The same would be true for like a zip code, for instance, that begins with a 0. You have to bring them in as strings in order to keep that format where there can be a 0 at the beginning of the number in quotes. So I'm running through now. I'm saying this particular layer is not going to be georeferenced. It doesn't have any latitude and longitude. So I'm basically just through new item and just browsing to that file. I could have done the Excel file. I could have done the comma separated value. I did the comma in this case. It's going to bring in those values. You do have to be real careful to make sure you change that HUC-8 to a string if in fact it's got zeros at the beginning of the number. So now I'm going to add in that table, and let's just take a look at it. And we can see that, yes, it brought the HUC in with the zeros in the front, which means it's a string, which means it will match, because that could be really frustrating sometimes. You think you've got the same numbers, but one's in an integer, one's in a string, and integers and strings can't match. They have to be the same format in the field. So now I've brought in, I'm going to show you how it's actually called a table join. It's under summarize data. And it's called join features. You're actually going to learn how to do the other type of join, a spatial join, next week. But this is just a table join, so I'm not doing a spatial relationship. I'm just going to combine a flat table, so a table that has no geographic information at all. So I have to say, what's the common field that they have, and it's that HUC-8. And they don't even have to be named the same thing. They do have to be in the same format. In this case, they were string. It's a 1-to-1 because I had 95 counties. I have 95 in the data file I'm bringing in. And then I have to give it some sort of a unique name because, remember, once again, all of these resulting layers that become our property get saved into this generic area at UT, even though we'll only see just our content when we go to our content. So I'm just giving it a name and running an analysis. So basically, I'm just joining these two tables just as if I copied and pasted the data into Excel. And this is one thing I did want to mention. You do have to be careful about using that current map extent, because if you're zoomed in, you're going to get your analysis chopped off by only what you can see in the map at the time. So I think some of you made an error on that on the last assignment, so do be careful with that. So, of course, now it's running through the analysis. I should, say that again. If you are zoomed in, if you just uncheck that use the current extent, then it will just do the analysis on the layer that you've said. The reason why they have that is that sometimes, you might have the whole U.S., but you're only trying to do data for your state, but you've got all of the data there. And if you don't set that to the current extent as you're zoomed into your state, it's going to try to do the analysis for the whole United States. So you do have to be a little careful with that option for sure. So now I'm going to just symbolize the watershed by this new field that I just brought in, which is the number of researchers. We can look at its table now, and you can see how they've joined over there. So we have the number of projects for each one of those hucks, and I'm going to go ahead and symbolize by the number of projects. So somebody wants to know how active research is in the watersheds in our state. So I switched it over to colors and amounts, and just classify the data so you get some, good little categories there. And that way you could give this to the report, so folks could see, which of the watersheds that are more being heavily researched versus others that don't have a lot of research going on. So this was just to show you some other different things you can do with tables that we haven't really had a chance to practice much in the class.